Astronomers study asteroids and comets, but usually from afar. But one NASA mission, OSIRIS-REx, found a way to study an asteroid very close up. It started in 2004 with an idea.
We are interested in how the solar system formed, how the Earth formed, and maybe how life formed. The problem is that the evidence of it on Earth is all messed up. Why we have such an active biosphere, we have active geology, that there are no really old rocks. And so if you go into space, you can get an old rock.
So NASA senior scientist Jason Dworkin and his team decided to build a spacecraft to get that old rock from an asteroid. But which one?
We needed an asteroid that we could get to and back in the lifetime of the team, with a rocket that you could build and afford. We also had to have an asteroid that was understood, that we had data on, that didn't spin too fast, and had the right types of chemistry.
They picked the asteroid Bennu.
It's a very featureless, very dark, barely reflective material. It's black as asphalt, and not many spectral features. So this is what's indicative of a very primitive, never melted, never altered material. That's what we want.
Bennu is as far as 200 million miles away from the Earth and has a 1 in 1,750 chance of actually hitting Earth in the late 2100s. So it was a good asteroid to learn more about. The OSIRIS-REx mission was launched in 2016 and arrived at Bennu in 2018. The spacecraft studied the surface of Bennu for 2 years before attempting to touch on its surface and take a sample of its rock.
It's a very rocky asteroid, much rockier than we thought, based on all the data we had ahead of time. So it took a while to find a safe spot, develop the new techniques that we needed to get to the safe spot, and then practice.
Practicing was tricky because it took 18.5 minutes to send a signal that far away. So in the end, the spacecraft had to be able to fly itself.
The plan was the spacecraft would detect that it had touched the surface by slowing down, by the long arm has a pogo stick and the spring would compress. And we also counted the seconds, how long it would be on the surface.
But when the spacecraft tried to take a sample from Bennu, scientists were in for a surprise.
It's not solid. It has holes inside. It's like a dust bunny. It's a giant, well, it's actually small as asteroids go. It's only half a kilometer across, but it's just a very fluffy, dusty rocks, barely held together by gravity.
The spacecraft was still able to get its sample, and once Bennu was in the right position, the spacecraft started a 2-year, 4-month journey back to Earth. On September 24, 2023, the spacecraft reached Earth and then released the capsule which held the rock sample. The capsule streaked through the atmosphere at 27,000 miles per hour. A small parachute was supposed to slow and stabilize its descent until a larger parachute could deploy. But that didn't happen. Both parachutes deployed at the same time.
Because the main chute was designed with lots of margin so that it could handle the extra force and extra load, and we're also very lucky, the landing was perfect.
Ground crews retrieved the capsule and got it into a temporary clean room set up in the Utah desert.
One of the things we're most interested in is getting what we call a pristine sample, a sample that has not been contaminated by Earth or by the spacecraft. And so to do this, we need to make sure that there's not air that gets in.
The capsule was then flown to the Johnson Space Center in Houston, where it was put into its own special clean room.
And inside of that clean room is a nitrogen glove box. So it's a box you put your hands through in gloves to work inside of, so that there's not even air inside, just pure nitrogen gas to keep the samples from getting contaminated.
Scientists studying the first examples found it was what they would have expected from rocks dating back to the beginnings of our solar system.
And it's black because it's full of carbon and full of magnetite, which is a mineral that's formed by interaction with water.
They also found a few things like high amounts of magnesium, sodium, and phosphorus, a combination they didn't expect. Scientists around the world and those in the future now have the opportunity to study Bennu's rock. And what about the main spacecraft? It was given a new name and a new job.
OSIRIS-APEX is the spacecraft without the sample canister, without the sample collection device. It is headed towards asteroid Apophis to reach there in 2029. and it'll study the asteroid as an object, just as OSIRIS-REx did for Bennu.
It took around 20 years for Dworkin to get his 4.5 billion year old rock, and now the real work can begin.
Planetary science is a game of patience. The rewards are immense. The best part of being a scientist or working at NASA is discovering something new, discovering something that no one has ever seen before, something unique, a correlation, something new in a meteorite or a Bennu sample, and then the excitement of seeing it and then telling everyone around it about it. Scientists can't keep quiet. We love telling everyone everything we've discovered, everything we've learned. It's just thrilling to share the knowledge.
If you want to learn more, head to the Science Trek website. You'll find facts, links, games, material for educators and parents, and much more. You'll find it all at sciencetrek.org.